Is it going? Is it work? It's working. How do you lose the middle of the last page, isn't it?
Yeah, the one with the fun number.
What's the fun number?
I'm like,
470.
we can make a slip and slide in our house using this one.
Lindsay is gone.
Hey, I was like 7.
Julia,
Okay.
gone.
I'll do my work on this side.
This Julia's here. Bailey? Oh, you are here. Sorry. You were behind Aaron this whole time. I can see you.
Behind Aaron. Eat a salad. Okay.
I could do it on the left side, and you can do it on the
Okay.
right side.
So,
Don't get on Winslow weight loss program.
Oh,
This is like, you'll lose 20 pounds.
As long as the wheelchair weighs less than you, you're fine.
after I cover this, guys, unless you have questions that you'd like me to discuss, we can just have a work day, I guess, for the rest of the class. So 69 says that there's I need to start just doing like how some buildings don't have a floor 13. Just it goes 12 to 14. Just skip that number. That is 21. I guess 21. That meme is so cutting edge that.
Yeah.
Do you guys see the memes that I was talking about yesterday yet?
Oh, the
E. Yeah.
George said it.
Yeah, George kept on saying that during practice.
Okay, so this says that the block is being pulled to the right with 100 Newton force. Okay, so that's 100 newtons of force at a 30-degree angle. And the block's going to end up getting pulled a distance of 10 meters. So that's going to be like the horizontal displacement. So eventually, the block ends up over here. It's 20 kilograms as well. Maybe I shouldn't put an M there. I should put 20 kilograms, right? Okay, so the question is, how much work was done on the block by the person pulling it? So the idea here is, it answers not 1,000. Okay, if you thought the answer was going to be 1,000, like how would you get 1,000? First of all, go and say, well, I know this formula: work equals force times distance, right? Well, the force is 100, the distance is 10, so it stands to reason there's 1,000 joules. But there's a problem here, which is that, can you imagine how, like, in an exaggerated one, let's say I exerted 100 newtons at an 89-degree angle, right? It's not going to make the block go very fast, is it? Because pretty much all of my effort is being, like, quote unquote wasted. Just kind of like, the block wouldn't lift off the ground, but I'd be kind of alleviating some of that weight. So obviously, if you exert 100 newtons at this angle, it's not the same as exerting 100 newtons at that angle. Does that make sense? It's built different, exactly, yes. Vanilla ice? Because to quote Vanilla Ice, it's not the same. It's not the same. So anyway, does anyone have an idea of what the calculation is going to be? So if I want to be technical, actually what I have to say is it's the force, it's actually just the force in the direction parallel to the movement. So we'd say it's the component of the force along that direction that counts.
So you're just finding like the X component?
Yeah, so really what I care about is this value here, this horizontal component. So, someone tell us, how big is that vector?
Hypotenuse.
Oh, 100 sinus.
That's cost.
Cosine.
Cosine.
100.
There's more than 2, you know.
How long are you doing?
30, 90.
So that vector there, that horizontal vector, is 100 times the cosine of the angle. Okay, so if you look up this formula, if you Google it, you might just see the formula written like this. Where F is like this number, F is the overall force, and then theta, of course, is the angle with respect to the direction of movement. And so anyway, what you get here is 100 times the cosine of 30 times 10, which is, can someone calculate that for us? What?
866.
Lit. Joules. Or Newton meters. Okay, so does that make sense? That's the work done on the block. How can I find out how fast the block is moving? Yep. So we know that the work is equal to the change in energy. This is a really important idea to understand, okay? If you want to learn about, I don't know why my W's have gotten progressively more like omegas. Sorry about that. They're supposed to be W's. Capital omega is like this, but lowercase omega looks like that.
Oh.
So the work is equal to the change in energy. Well, how much energy did he have at the beginning? 0. So the change in energy is just the gain in kinetic energy, right? So like Kate said, I'm just going to set my work, 866, equal to the 1/2, oh, it's 20, isn't it? 1/2 times 20 times v squared. If you solve that, you should get, I don't know, 9 point something. What is it?
9.3.
It's moving.
That's pretty fast, yeah. Okay, so hopefully 70, the last problem, is pretty straightforward. After you see that, okay. Intent. And then you'll end up with a general formula for the final velocity in terms of the distance and theta. So here's something. Does the mass of the block matter for this question?
Yes. They don't cancel out.
Did the mass matter for this number?
No.
No, the mass did not affect this number because, well, all it is the force time, and then you have theta. You have theta, the force, and the distance. But when you actually calculate the velocity, you do have to account for the mass. The bigger the mass, the smaller that velocity is going to be, which hopefully agrees with your common sense, right?
Yes.
If you push a light block, you can push it faster than pushing a really heavy one. So, poor Kate, so sleepy. Are there any others on here that you want to discuss before we just have work time? Yeah.
Could you do, or just talk about 50 or 51?
51.
It's like the
Could be
block
one.
just going up the pure vertical round.
Pure vertical. Thanks, Kate. Oh, so yeah, that's the one where the ramp is like this.
So you got an EDVX?
I'll just ask you this: does the shape of the ramp matter?
No.
Nope. And then let's suppose we ask the question: what's happening at the moment when a block? So say the block is traveling with some velocity. Can I quantify the energy? 1 FMV squared, right? And then what happens when the block reaches its max height? There's potential energy, there's certainly MGH. How much kinetic energy is there up there?
Zero.
Right, because your velocity is 0. If it's changing directions, then its velocity is 0, right?
Yeah.
So, so the moral of the story here is that that mathematically speaking, a block sliding up a frictionless ramp is kind of identical to like shooting a cannonball straight up in the air, or it's kind of inverse to dropping a ball off a building or something like that. Okay, so does that clarify that?
Yeah.
Anything else, guys? Anything else? Anything else? No? Okay. That's it for the stream today then. Thanks for the 100 bits.